This is Frying Bacon Studios for Game Salad Logic Part 7. One of the reasons why I've been so adept at grasping game salad logic is because in the last 30 years, as an industrial electrician, most of my work has been in control systems in large power facilities across the United States. These are basically hardwired control systems, some of which do connect to software control systems. Usually when there's a problem in a facility like this, the components that all come back to this control room, which behind those boards are tens of thousands of connections, can be scattered out a large facility all over the place. Usually when there's a problem, we'll have to reference 10 to 20 different schematics, drawings, and reference documents to figure out what's going on. If you don't understand logic, you can't even begin to troubleshoot the problem. So usually we look at what's working, what's not working, referencing the documents, looking usually at a ladder schematic, which is a straight linear example of how everything's connected together, narrowing it down to a particular item, and then finding that in the facility to see if there is a problem there, testing out the wiring, and correcting the issues. This can be a daunting task, especially in a facility like this, because if you lift one wrong wire, this can cause the generation facility to shut down, and that can cost upwards of $1 million. So in Game Salad, you don't have quite as much pressure, but in my business, you get only one chance to get it right, and you better be right. So you have to know your logic and understand what's going on and evaluating things. We deal with very complex schematics, as you see in this picture, all the time. Now this is one of the simpler ones for us, but as you can see, if you've never dealt with this, it's pretty advanced. But it does give you a basic idea of how logic works. Now one of the things that's interesting is that you deal in logic every day, even though you don't even know it. So I'm going to take some of my experience in this area, and I'm going to show you how logic can be applied from the electrical into Game Salad, as since software theory has been based on hardwired electronics. So let's go ahead and look at some of the basic circuits that you might use every day in your home to get you to understand how they relate to rules and attributes and behaviors in Game Salad. Most of us deal with control circuits every day. We just don't realize it. This is a basic setup of a schematic of a light switch and a light in your home. This is basic logic. As we know in computers, that logic is ones and zeros, on or off. That's all that can be in any condition in a computer. It's a series of switches inside chips that either are on or off. Now we can take and translate these ideas and put them before you in a linear fashion so that you can understand kind of what's going on in the behavior path, as this is very similar to software coding. So as we see, I've put up here rule. Rule, I would consider, would be the basic wiring that connects everything together, as they're all contained inside a rule, your attributes that trigger the rule, and your behaviors that are the execution of the rule. So as we can see here, in this electrical circuit, the electrons are allowed to flow up to this point, but because the switch is not mechanically made, that the two pieces of metal haven't come together, the electricity is not allowed to flow to the light and make it activate. This is very similar to a condition of any kind of attribute in your rules. They don't allow it to go forward and to make the behaviors execute. So if we see here, the condition of coming over and turning on a switch changes everything. So as now we close the switch, which you do mechanically, but it's done in software in a computer, but they're the same actions. The current can now come up and flow through the switch, come down, and turn the light on, which would be similar to activating a move to behavior or any kind of other behavior that you want to execute in Game Salad. Now let's look at this as a very simple situation. Let's get it a little more complex, and let's show you with two switches. So now here we have two switches, both open. This would be considered another attribute in Game Salad. This is where we begin to stack or put multiple conditions in series. This would be the all condition in Game Salad, in that all of these events will have to happen for this to turn on. So thereby, if we went in and turned on the first switch only, we would see that the light can't come on because this is blocking the circuit. It's still open. The pathway of electricity can't continue. This is similar to having multiple attributes in GameSalad, that all the conditions need to be met before the behaviors can activate. So if we came over and we closed the next switch, now we see that the light will turn on. This is very similar to what happens in GameSalad when you have it on the all condition in a rule. In other words, all these conditions, attributes, or switches must be in their proper position in order for the behaviors to activate. You could do this in the reverse as well in GameSalad. In other words, we could make a condition where both switches need to be open for the condition to happen. That by both of these conditions are open, the behavior would still activate. It's still logic. Even though it's not straight electrical, you begin to understand the principles of how logic works and how things are ordered in a series of events. And then we also have the any condition. In the any condition, what would happen is if either one of these switches were closed, even though we have two of them, the event will still happen because any means either one of these conditions would turn the light on. Now this would be drawn different in an electrical scenario, but it's similar in principle. I think you get the basic idea of how I'm trying to teach you how to think logically. And we can see that it can get as complex as you want. So it's a good idea to really begin to think about your GameSalad in a logical order, in a fashion. And by showing you this demonstration, I think it starts to help you start to think about things as interconnected, almost mechanically, even though they're done in software. They're the exact same types of theories and methodologies. In fact, software logic derives its basis from electrical control systems logic. It simply replaced all the hardwire that used to be done with software. I hope this helps you begin to think about GameSalad logic in a different way. We'll keep continuing on this series and helping you design and optimize better efficient code in GameSalad. This is Fry and Bacon Studios. I'll see you in the next tutorial.